The last video is about goal 8. So what we're going to do is have to look at these graphs to figure out how to read them and understand what's going on. So if we compare the two graphs here, we can see that one of them shows two objects together. And right at this point, what's happening is mass 1, or cart 1 rather, mass of cart 1, is now moving at a different velocity than cart 2. So this would be more of an explosion type scenario where you have your two carts like this and they're together, and then the plunger, you push it and it pushes out, the spring releases, this guy goes flying this way, this guy is flying that way. So this would be more of an explosion type reaction or collision. Here, this graph, we've got two carts that are obviously moving, well, this guy's moving at 10 meters per second. This one must be at rest, but they connect together. So this must be a scenario where one guy is moving along, he hits another cart that's at rest, and then what happens is they move on stuck together with the same velocity, both of them. All right, so I just wanted to show you how to read those. So if we go on to the questions, which graphs show a cart explosion? So we just learned how to recognize that. That would be graph 3 would be an explosion. But also, if we look over here, this would be an explosion as well because they're together and then they separate. So we're going to say graph 3, oops, you can't see that, graph 3 and 5 would be explosions. That means the other ones, we're calling them a sticky collision. That would be this one. They're separate and then they go together. And then over here, graph 4 was the other one. So graph 4 and 6 show a sticky collision. So in which of the graphs are the masses of the cart equal? All right, and that would be the graphs where they have the same change. So if you look at these two pictures, we've got the carts together, but when cart 1 explodes away, it goes at a speed of 7, and cart 2 down here is also going at a speed of 7, just in opposite directions. Here, this guy's at 10, it shifts down and it's going 5. This one's 0, but it moves up to 5. So in both of these pictures, they're both changing the same amount. So we can assume the masses of the cars are the same. So I would say in graph 3 and 4, the carts are equal mass. But if you take a look at graph 5 and 6, you can tell when these guys are together, this one, cart 1, only changes to 2 meters per second, where the other cart changes down to -8. So it's going way faster. So you can kind of picture this. This guy probably has a bunch of weights on it. This guy's probably light. And when they push out from each other, okay, cart 2 goes much faster. So if we call this cart 1 and cart 2, this guy is going to go flying off much faster than this one because he's so heavy. So we can conclude that this guy has a bigger mass because he doesn't change as much. All right. When they ask us for what's the change in the velocity of cart 2 in graph 4, so if I look for graph 4, change in velocity of cart 2, I just have to find the right graph, find the right cart. Cart 2 would be the line down here. And you have to remember to find change in velocity. Change in velocity is really final velocity minus initial velocity. So I'm going to look for my final velocity, and it would be 5. My starting velocity would be 0, so my change in velocity is 5 meters per second. So that would go in here. The change in velocity of cart 2 in graph 4 would be 5 meters per second. And then the last question, if the cart, we're looking at graph 6, so that's this graph right here. We're looking at cart 1, so we're looking at the one with the triangles. They're saying if the cart has a mass of 0.5 kilograms, what's the momentum after the collision? So all we're doing is we're going to use our momentum equation. They're telling us the mass is 0.5. So all we need to know is what's the velocity after the collision. So if we look right here, the velocity after the collision is 5. So I'm going to take 0.5 times 5, and that's going to end up being 0.5 times 5 is 5 times 5 is 25. but then we're going to move the decimal over, and it's going to be 2.5. So 2.5 kilograms times meters per second would be the momentum.